Hey, what's up, everybody? Today is February 5th, 2025. We're going to go ahead and do our Leetcode daily problem today. I had a gander at it a little earlier, so I have an idea about how to solve it. I had to think about it because this one was kind of tough. But I'll explain what I was thinking before and the conclusions I came to. Let's go ahead and practice our typing speed, or fingers. Let's begin. Take I noticed that whenever I make a typo, it really makes my typing speed suffer. Okay, here's the problem of the day. 1726, tuple with the same product. Given an array nums of distinct positive integers, return the number of tuples a, b, c, d, such that a times b equals c times d, where a, b, c, and d are elements of nums, and a does not equal b, does not equal c, does not equal d. So basically, we're looking for pairs, and we're looking for a frequency of pairs. So if you get two pairs that happen to be the same thing, then we know that we have 8 valid sequences or permutations of the same values. Now, originally I was going to use a well, okay, to be fair, the brute force method, which is O of n to the fourth, was just 4 for loops, and you check every indice and check everything. Now, obviously, that's going to TLE. There's no way that's going to pass. The second thing that I was thinking about is that we know that if we find a valid pair, we can hash the number and then use that to count for every time we get an additional pair, because we need 2 pairs to equal the same thing. But if we get, so 2 pairs is basically equals 8, right? Yeah, and so every time you would find a new one, you'd basically multiply the number of pairs minus 1, because you start from 0, right? If you pick up 1 pair, obviously there's 0 because we need 4 elements. If we get 1, we know one set of 4. We know that creates 8 valid tuples, right? If we say have 6 values or 3 indices, we know that that's going to be another 8 on top of that, correct? And so we would just add the results. Because if you look here, 1, 10, 2, 5, right? And they use every combination here. 1, 10, 2, 5, 1, 10, 2, 5, whatever. And then we have 2, 10, 4, 5. And then they do the exact same thing here. So they added an additional 8 because they have one more valid pair that they could use for the numbers, right? And I was trying all sorts of stuff before this solution, but it definitely makes sense, because if we have 2 for loops, like this, we know that we're going to get every unique combination. Well, not everyone. They're not going to be flipped. So you're going to get every unique IJ combination of elements that for those product pairs, right? And we can just multiply every valid IJ pair for a product and add that as like kind of in the frequency map, right? So if we had a frequency map, and we did something like, well, let's so we have a product which is nums I times nums j. Then we know that if we go frequency product times 8. So it starts out as 0. Okay. We have our product. So it's going to be start out as 0, right? And then we multiply it by 8. And then this value is going to be added to a result. And then we're just going to go like this, right? So it starts out as 0. So we add 0 if we find one pair. If we find a second pair, this will become 1. We'll multiply it by 8, add 8 to the result. 2 pairs becomes 8. And same thing, if we find another pair, we're going to basically do the same thing. I believe that's correct. Is it plus equals or equals? For every pair for the product. Yeah, that has to be it. Right? Yeah. I think that applies to pretty much everything. Now, this should give us a Oven squared solution, and at 1,000, that should be fine, I think. Definitely better than O to the 4th, into the 4th. I'm not quite certain how to make this any better. Because we're getting everything unique. It's in Oven squared. Let's just submit. Yeah. So let's go ahead and see what the editorial did. Sort the array in increasing order, initialize. Oh, this is basically what we did. This is originally what I was thinking about doing, but I went multiple ways of doing it. To be fair, I was I was actually originally trying to think about the two sums problem, and then having a times b equal x prime, and c times d equals y prime, and then you found one value, and then you looked for the other value. But I couldn't figure out how to separate the indices or make sure they're unique indices in some way. I don't know. It was very confusing. See, if they're sorting here again, you don't need to sort. This gives you all the unique indices. Oh, this is a little like how the first way I wanted to do it, though. Product frequency hash map. Okay, size, frequency. Okay, they took the product, added up to the counter. int pairs of equal product, product minus 1 times product divided by 2. Calculate the number of ways two pairs with the same product. Is this like combinatorics? Of course, this is O and squared. I think this solution is actually better than this one. N times n minus 1 over 2. Math, yes. That's funny. Yeah, I think a lot of people had similar ideas. Whoa, look at this one. The hash map times 8. Oh yeah, you can get it down to another line. You don't really need the product like this. You just put it here and here. Yeah. Okay. Well, that's my solution to the product problem today. I hope you enjoyed that insight into the problem, and I hope you have a wonderful day. Peace.